Okay, so here's the question. We have Bubba Airlines says that it has an on-time percentage of 80%, which means that on any single flight, there's an 80% chance that we'll be on time. So here's the question. If you fly 8 flights on Bubba Airlines, what is the probability that exactly 6 of them will be on time? So let's think about that. Here's our 8 airlines. Excuse me, our 8 flights. Okay? So let's just apply a number to them. So here's 0.8. Say this one's on time. This one's on time. This one's on time. This one's late. This one's on time. This one's on time. This one's late. And this one's on time. So the probability of my first one being on time, second on time, third on time, fourth late, fifth on time, sixth on time, 7 late, 8 on time is going to be 0.8 to the 6th times 0.2 to the 2nd. And that number, here's my calculator, so 0.8 to the 6th times 0.2 to the 2nd gives me a 0.01 chance. Now that seems low, right? The reason it's low is because that's this specific order of planes, that it's on time, on time, on time, late, on time, late, on time. But all other things can happen. So the question is, how many different ways can this configuration of 6 on time and 2 late happen? And if you think about it, it's really just how many ways can I choose 2 of these planes out of the 8? So it's going to be an 8, choose 2. Okay? So that's how many ways this can happen. And so if I take this number, 0.01, times 8, choose, that's number 3 here, choose 2. Oops. Gotta get out of there. There's my answer. So my answer there is 29%. Okay, so there's a 29% chance that exactly 6 of them will be on time. Okay, now it could be that 7 are on time or 8 are on time. So there's all different possibilities. So let's look at that again. Here's 8 planes again. But let's think what can happen. And here's a way to think about it. Is if I take 0.8 plus 0.2 to the 8th, I know that that's 0.8 plus 2 is 1. This is 1 on this side. This is going to be, if I expand it using my binomial expansion, 0.8 to the 8th plus 0.8 to the 7th times 0.2 plus 0.8 to the 6th times 0.2 squared plus 0.8 to the 5th times 0.2 cubed, wishing I'd chosen a smaller number, plus, I'll just continue it on, and I'm going to end with 0.2 to the 8th. Okay, and what that means is that this is the number of ways to, oh, I'm sorry, then I have to put the coefficients in, which I'm going to pause my calculator, and I'm just going to write those in. Okay, I pulled out that page from Pascal's triangle, that line. I could do it directly. So I have 1, 8, 28, 56, and so on, all the way back down to 1 here. Okay, so each of these lines, each of these terms gives me a different piece of information. So this is the probability of 8 on time. And this is the probability of 7 on time, and this is the probability of exactly 6 on time, and 5 on time, and if I count all the way down, this is the probability of 0 on time, and if I add up all those probabilities, I get a 1. Okay? So let's solve one more problem directly. Soccer goalie can save 95% of penalty kicks against. What's the probability of the goalie saving exactly 7 out of 9? So my probability of success is 0.95. And I want 7 successes. and the probability of failure is 0.05, and I have 2 failures, and I know that I'm taking 9 shots, and I want to have 7 successes, so 9 choose 7 is my number, and that's the answer to my question, the probability of the goalie saving those shots. So I'll pop that in my calculator, and I'll do 9 math probability 3 7. I always overuse parentheses. 0.95 to the 7th times 0.05 to the 2nd. And press enter, and it's 0.06. So there's 6% chance that the goalie will stop 7 out of 9, and that might seem low, but if you think about it, the probability is, well, you know what, let's do it. You can always stop the video, you know. So if I wanted to know for 8 shots, I can do second enter, and I can come back here, I'll go back to the beginning, and I want 9 choose 8. And I'm going to make it 0.95 to the 8th, and 0.05 to the 1st, okay, because there's one failure and 8 successes, and if I press enter, now we're up to 30%. And if I wanted to know all 9, that's a little more direct. I can just do 0.95 to the 9th. And that's going to give me 0.63. Okay, so the probability of stopping, now if I change the problem to at least 7 shots, that means 7, 8, or 9. So then I'd add all of these, and I'm getting a sort of a 99% chance that they'll stop at least 7. Okay, pretty unlikely that they let in exactly 6 or fewer. Okay, so there you go.